Hi, guys. Okay, so now we're starting GCF with polynomials. Well, you might see it labeled as factoring polynomials. And then this is specifically talking about finding the GCF, which is always the first step. Okay, so to practice this, right now what this looks like is the GCF times everything else. So we are now going to simplify, which means I'm going to multiply. So I'm going to do a times 3a, which gives me 3a squared. Then I'm going to do a times 7, which gives me 7a. And then again, I'm taking the GCF and multiplying it times everything else. So I'm going to do 2m times m squared. I'm sorry, negative 2m. So I'm going to have negative 2m cubed. Then I'm going to do 2m times 6m. And that's going to give me a negative, I keep saying negative 2m. It's a negative 12m squared. And then I'm going to do negative 2m times a negative 1. We've got to remember that's a negative 1. So this becomes plus 2m. And this is the polynomial. Now we're going to do the third one here. So I'm going to do 4x to the third y times x squared. Remember, when we're multiplying, we add the exponents. So this is going to become 4x to the fifth y. There's no y in this one, so I don't have to worry about adding anything to the y. Then we have 4x to the third times negative 2y. So I'm going to have negative 8. There's no x's in this term, so I'm going to have x to the third, but there is a y. This is understood to have a 1 here and a 1 here, so this is going to become y squared. And what we're doing today is we're going from this polynomial back to this form here. Okay, so to define factoring, it is separating a polynomial back into a product. Separating a polynomial back into a product. I like for it to think about it as looking at the GCF times what's left after you take out that GCF. That's the way I look at it. Okay, so for instance, if I have 4a squared plus 8a, my goal is to get it into factored form. The way I like to think about these is I find the prime factorization or a factorization with a common term. Okay. If you do prime factorization, you'll always get to it. So that's what we're going to do for this one right here. So I'm going to have 4a squared, and the prime factorization for that is going to be 2 times a times a, because I want prime numbers. And then I'm going to do the prime factorization for 8a, which is going to be 2 times 2 times 2 times a. And now what I'm going to do different here at this point, this is where I'm finding my GCF. The GCF is the greatest common factors. So I'm finding the things that are the same between the two. They have 2 sets of 2's and a set of a's that are the same. So my GCF is 2 times a, which gives me 4a as my GCF. So we have 4a, open parentheses, that's my GCF. Now what's left in each part? An a in the 4a squared, so I'm going to have a plus what's left in the second term, a 2. So we have a plus 2 inside the parentheses. And this is my polynomial in factored form. I'm sorry, but this is factored form, the products. This is my polynomial. Okay. Polynomials that cannot be factored are called prime. That means they don't have a GCF, or we will learn in the next couple of days, but they are called prime. You write the word prime when you cannot factor it. All right, moving right along. Okay, there are several factoring methods. The approach depends on the polynomial. We will start with identifying and factoring out the greatest common factor. This is what we're going to do first. Okay, and you always do this first. You always look for the GCF first. Okay, check the coefficients for a GCF, and that can be done. We're going to add a little note here. Right. Prime factorization. This is a surefire way of always finding your GCF. Prime factorization. Right, prime factorization for each term and circle. Could have written this in this box over here. Shame on me. And circle what is same. Then simplify to get GCF. That's going to be your steps for finding that GCF. Okay, so you can check the coefficients for a GCF. Now look at the variables. A variable must be present in all terms to be a GCF. If a variable is present in all terms, take the one with the smallest exponent. Okay, this is another way that you can think about it, but sometimes that can get confusing, but it's your choice. Either way, you've got to make sure that you're showing me what your thinking is. Divide each term by the GCF and leave the remaining factors in parentheses. And that's where we get the GCF times what's left. And you check your work by remultiplying. All right, let's work a couple of examples now. Looking at number 2, I'm looking to see what is my GCF. Okay, by not using the prime factorization, I can look at them and see, oh, both of these have a 7 in it. I can divide each one by 7. There's no variables that are the same. So now when I do this, I have my GCF on the outside, and I'm going to have what's left. So when I do 7 divided by 7, that equals just y. The 7s are gone. 7 divided by 7 here is 1, because it's actually a 1. We just don't write that here. So this is my final answer here. And my work for this was just dividing by the 7, because that was my GCF. My GCF here is 7. And you want to make sure that you kind of say that as well. All right, looking at number 3. Okay, I'm going to look at, I'm not going to necessarily write the prime factorization for this, but I'm going to think about what's a common factor. So if I have 8m, that's a 4 times 2 times m. If I think about 36n, well, that's 4 times 9 times n. And if you don't see that, you can always go all the way down to the prime factorization if you don't see what the GCF right way is. So I circle what's common, nothing else the same, so that my GCF is 4. So I'm going to have 4 times what's left, 2m plus 2n. And there's my answer. And if you automatically see that it's a 4, then you can just go and do this division by 4. But you have to tell me what your GCF is. Just some of you may need to do this, and that's okay. All right, next example. We're going to go to the next page. We're going to move on to number 14. Again, if you've got questions, rewatch or come ask me as you're working these, please. So if I'm looking at 14, okay, for this is where I'm going to look at, okay, I've got a little bit bigger numbers here, and I don't honestly know if 18 goes all the way into 48. So I'm going to think about smaller numbers, and I'm going to see, okay, 6 goes into 18 evenly, 6 goes into 48 evenly. I don't know if there's anything bigger, but I'm going to start there because that's the numbers that I know. And if I don't even know that, I'm going to start with 2 and break it down from there. So I'm going to write my prime factorizations of 18 a squared b squared equals, so let's see, 18. Here, I'm going to write that below. Okay, so I have 18 a squared b, it's just b, c squared. So that's going to give me 6 times 3 times A times A times B times C times C. Then I have negative 48 A, B, C to the third. So that's going to be 6 times 8 times A times B times C times C times C. Oh, I'm going to make that a negative 8 because I remember that's a negative 48. Okay, so what's the same? So when I'm looking at this, my 6's are the same. I've got a set of A's that are the same. I've got a set of B's that are the same. And I have 2 sets of C's that are the same. So that means right now my GCF is going to be 6AB C squared. And now I write, well, I'm going to write what's left. So I'm going to have 6ABC squared, and then I've got what's left inside. So I'm going to have 3A, because I have this 3, and I have this A right here. And then I'm going to write what's left in the second one. Now that, remember, that's a negative 8. So this is going to be minus 8C. This is my factored form. And if you've got a question, make sure that you come and ask. All right, looking at number 18. Okay, I pulled this one just because it's got higher exponents, so we can make sure we understand this. But, okay, so I have 12 A to the 5th B squared. So that's going to be, if I think about it and I look at all of my numbers, I can see a 6 is going to be probably the highest number that will go into all. So I'm going to have 6 times A times A times A times A. 1, 2, 3, 4, 5. Negative 36. A to the 4th. B to the 3rd. And I forgot about the B's right here. Okay, put those back up there. And so I'm going to have 6 times negative 6. And I have A times A times A times A times B times B times B. And then I have negative 6 A squared B squared equals, so that's going to be 6 times negative 1. The reason that I'm doing this is because I want to have something that's all the same in here to be able to circle. Times A times A times B times B. So now when I'm looking here, I'm circling my common terms. So I've got the 6's. I've got a set of A's. I have another set of A's. And I have 2 sets of B's, if I look at this. So I'm going to have 6A squared B squared times A to the 3rd minus 6. I'm going to have to do this off to the side because I didn't leave myself enough room. Some of these boxes are too small. So I'm going to have my answer. I'm going to write it off to here. So I'm going to have 6A squared B squared, and then that's going to leave me with A to the 3rd. Oh, I forgot the 2. I knew there was something wrong up here because it's times 2. So we have, that's 2A to the 3rd. 2A to the 3rd minus 6A squared B minus 1. And this is the final factored form for number 18. All right, let's look at 24. Okay. Now, doing this prime factorization may get cumbersome at times. That's where you can look at the exponents. Okay. Well, my first that I noticed, I'm going to look at my coefficients, and the largest number that will go into all three is a 3. Now I'm looking at my variables. What's the smallest a variable? This one right here, a to the 1. So I'm going to have an a. Looking at the b's, what's the smallest b variable? B squared. What's the smallest c variable? C. So that means each one is going to be divided by 3ab squared c, because my GCF is 3ab squared c. I know that already. AB squared c. That's my GCF. Now what I got to do is figure out what am I left with. So when I do 3 divided by 3, that equals 1. A to the third divided by a, that leaves me with a squared. B squared divided by b squared, that just cancels out. They're the exact same. The c's just cancel out because they're the exact same. So all I'm left with is a squared. Now I'll look at my next term. -9 divided by 3. That's going to give me a -3. Now I'll look at my a's. A squared divided by a. That leaves me with just a. B to the third divided by b squared. Remember, you subtract the exponents. That means I'm doing 2 minus 1 for the a's, 3 minus 2 for the b's. So that gives me 3ab, and 2 minus 1 for the c's. So that gives me 3abc for the second term of what's left. Now I'll look at the third one. 15 divided by 3. That gives me 5. A to the first divided by a, that just cancels out. B to the fourth divided by b squared, I do 4 minus 2. So that gives me b squared. C to the third minus c, that means doing 3 minus 1. So that gives me 2. So that's c squared. So my final answer, final factored form, is 3ab squared c times a squared minus 3abc plus 5b squared c squared. That is a lot of letters, and it's very tedious. You have to pay attention to those details. Okay, so go through. You're going to finish up the notes and the classwork homework. Okay, we may adjust the classwork homework assignment. We'll see how time goes. Okay, all right, y'all have a great day. Bye.